Good morning once again. Thank you for joining today. Today is day two of Video Foundation course. Okay, and we had good participation yesterday. Believe over 100 people attended, and I had shared the quiz link. You might have received it as well. So feel free to attempt it. Above the quiz, attendance is mandatory as per the policy of the Big C. Okay. There are some exceptions that can be done for on case by case basis. Um, However, feel free to get in touch with me if you have any challenges about it. All right. So yesterday we covered the fundamentals, and I hope that was useful to you. Today we have very interesting topics to cover, and I'm also very excited to cover these topics. And let's get started then. Yeah. All right, and feel free to ask any questions on the Q&A section or in the chat window. Feel free to ask as and when that particular topic is being covered. I will look through the Q&A. If it is related to the topic, I will immediately answer the question. Okay. All right. So running through what we covered yesterday, course content, day one, we talked about how to identify a good vendor for your project. There are many vendors in the market, just like anything that you buy. There are plenty of suppliers and catering to different requirements, and but there are also vendors that may not be suitable for your project. So that is something you need to identify which vendor is not suitable here, and you can go through the checklist that we saw yesterday and then take a call. Then we talked about camera, breaking down of the camera, the hardware, the physical aspect of the camera, the construction, metallic, plastic. Then we talked about the, let me go to that slide, we will not dwell too much on it. Let me just quickly show you. So we saw about this camera components. What are the different types of camera components? Body, bubble, lens, system on chip, SoC. Then we saw the software, excuse me. We saw the software that is running on the camera. What is that software? That's the web page. When you access the web page, you're having an interface. You're communicating with the camera. So what is that web page? If you recollect, you go to the IP address, it will take you to the web page of the camera. This interface, this is the web page of the camera. So this interface is basically a software. All right. And how good that software is, it's actually it makes the configuration team easier. It makes integration easier. It makes it's like getting the best use of the hardware. It's also dependent on the software. Okay. And also time consumption, how efficiently you can configure the camera. You don't have to go back and forth between different menu options. If you can do it all in that particular section itself. For example, if I come back here, one key example that I gave you was when you're making some changes to the camera, sorry, you can directly see what is the application. I have used other companies or even older models or older versions of certain brands, where every time you make a change you have to go to another window and check what is different. So you have to take a snapshot and check previously and after. So these kind of things can be eliminated with a better software functionality on the cameras. There are many good brands who have this kind of option for large projects. When, let's say, you're doing a city surveillance project, right, on, you have many operators who are constantly monitoring the camera, making some changes there. If you have if you're doing this on a daily basis, um, I mean, city surveillance with 10,000 cameras, right? 5,000 cameras. If you're doing this on a daily basis, these kind of improvements make a difference. Okay. Next is the classification of the camera itself. Um, the camera, uh, it's like this. Your mobile phone is basically for calling, same way your CCTV camera is basically for recording video, but you can enhance it with additional microphone for receiving audio. Also you can enhance it with alarm inputs and outputs, other functionalities like SD card, illuminators, to make the function of the camera much more powerful, right? More functional. Okay. All right. Then we talked about the chipset. Chipset is responsible for everything. We talked about the breakdown of the camera. It starts with the lens, sensor, processing, and then compression, and then and the camera sends out through the network cable. We saw CMOS, CCD sensor, WDR. WDR is two different lighting conditions in the same scene, two different contrasting lighting conditions. You will require WDR technology to take the best of both and give you a single image. It requires more processor simply because you need to merge two pictures in the same time. So a normal camera will only process one image. A WDR function camera will do it twice as fast. So back then, it used to be a separate range of cameras called WDR cameras. Even in the mobile phones, there initially they call it HDR. So not every model had it in the start. Nowadays, you find it quite often. A good camera brand um, will have HDR functionality done because it is related to the chipset processing, and processor is where the money is. Just like your laptop, you buy i5, i3, i7, all can do, but higher the processor, more the cost. So it is also related to cost. Next is highlight compensation. We saw about this where the bright lights can be masked to reduce the blooming effect. Then we talked about f-stop. It is inversely proportional. Higher the number, smaller the light gathering capability. So low light cameras make use of this special lenses which can open much wider to give you color picture in night time. Later on we saw what if you don't have any light at all, you need IR camera. Then we talked about focal length. Every camera has got special lenses. They will not, they will, I mean, the cameras can have three types of lens. A fixed lens means 2.8 mm, that's it. You will not have uh, dash 12, it will only say 2.8. That means it's a fixed lens camera. But there are majority of the cameras which is having a range, allowing you the flexibility, because this is what is used 99% of the time. So I showed you a scene, most of you will try to view as wide as possible, right? As when the focal length is small, you will see as wide as possible. So we saw this yesterday, the live demonstration. Then we talked about uh, field of view, detection, recognition, identification, and strong identification. Okay, not able to check. Okay, just a second. I have a question. Some just if anyone is not able to connect by GoToWebinar, most of you have connected. I'm just in the chat. I'm putting a Teams, Microsoft Teams link. So if at all any of you want to share this link with specifically to someone, just you can share it. But keep do send me an email that you're joining by Teams because we're not tracking who's attending via Teams. Okay. So let's go forward. All right. So we talked about the DORIS standard. DORIS standard is not some man-made standard. It is a global standard. We saw that it is EN standard 62676, and there is another EN 50132, I believe. EN 50132. There is another standard also. So roughly, this criteria is globally used. Okay, this criteria is globally used for just yeah. So this standard is globally used for coverage study of cameras. Now you might have customers asking you, I have a camera here. Can I see the face at 100 meters? Yes, you can even see the moon at millions of kilometers. But what do you want to see? Do you want to detect any change in the scene? Then there is a criteria. All right. Seeing is not the thing. It is called detection. I means the operator sitting in the control room, he should be able to detect with his eyes when he's looking in the monitor that there is some intruder in that particular scene. So this is something, there is a criteria for it, and you have to keep this in mind. All right. Detection is minimum. Any CCTV camera should do at least this detection, or if they want, there is one more standard, monitoring 5%. But for most professionals, most to design, the criteria is minimum detection. An operator should be able to detect. All right. Now, another important point here, this minimum detection is for the operator to detect, a human being to detect. There are some analytics in the cameras. The camera itself will automatically detect changes. Okay, that is different criteria. That criteria may be higher because that is computer itself, or the camera itself is detecting motion or something like that. That um, may have more. Okay, which is maybe instead of 20, maybe it is 40 pixels, something like that. But for a human being, this is the criteria, 20 to 50 pixels. Okay, so this also you have to keep in mind, because let's say you're designing a project for perimeter and you're doing coverage study using this 20 pixel criteria. Okay, fine. But then you're also having analytics in the perimeter, and you're saying the camera will detect if there is any motion at 20 pixels. No, maybe that particular brand of camera cannot do it at 20 pixels. Okay, if it is uh, so I hope you got the idea. So the idea is camera doing analytics to detect, that is higher than the standard human being requirement. So this pixel is for human being to detect the changes in the scene. All right, so we do design based on this. Okay, so yesterday we saw how to do the design drawing using our Wisenet tool. Today, let me show you. There is also a third-party tool, but I believe they are. It is paid tool, but it is commonly used. I have been using this for over 10 years. Back then, it used to be very affordable. Now they have increased the price, but they have a free version, which you can have a basic idea. Let's say you are not comfortable to use our tool because it is having our logo on the top, or you're not, you want to, I mean, just for your information, the coverage study is independent of the brand. Actually, it only depends on the size, sensor size, the the focal length, and the resolution. Okay, sensor size has some importance, mainly focal length and resolution. So you can use any tool roughly. Okay, uh, but why a certain brand is involved here is, you may have designed a camera coverage with 2 mm. Maybe you decided I will give 2 mm, but you will not find any brand supplying 2 mm lens. Okay, so that is why it is, vendors also have coverage tools. So we saw our tool yesterday, uh, with our cameras. So yesterday I used a box camera. Okay, when I go to toolbox, right now we are still doing the revision. We still haven't started today's topic yet. So for those who are joining newly today, um, you might, you might see that, oh, he is covering too fast. Okay, just please hold on. We are yet to cover today's topic. I'm just revising what we have we did yesterday. So here, yesterday I had taken in the toolbox, I just took any box camera you can take, because box camera, you can put whatever lens you want. Okay, I did not take specifically bullet or dome, which is coming with built-in lens. For a basic example, I took a box camera to do the field of view study. Okay, so you can change the lens here and check. Okay, so how to do here in the third party tool? The third party tool is called jbsg.com, jbsg.com, um, jbsg. Okay, here there is an option called IP design or camera lens calculator. Click on this, and this is not part of the quiz, so this is just for information. Uh, Good to know that they also support brands, because maybe you are inclined to a specific brand they and you want to do the coverage based on that. That is up to you. You can do a general calculation. These two are optional field. If you see this tool, it is not mandatory that you need to put a brand name. It is not mandatory you need to put a model. Okay, what is required? Sensor size. What is sensor we saw yesterday? The image, the sensor, which is where the I mean light signal is converted to electric signals. All right. So sensor size 1 by 3, 1 by 2.8, 1 by 2.7, 1 by 2.5. Which one to take? Okay. So if you take um, any camera, let's say XND 6080, or this is a standard 2 megapixel camera, you will see here the sensor sizes is 1 by 2.8 inch. Most CCTV brands they use 1 by 2.8 inch. Okay, calculator, 1 divided by 2.8. 1 divided by 2.8 is 0.35. Some brands, low cost brands, may have 1 by 4 inch. Okay, so 1 divided by 4, it's 0.25. So it's around 30% smaller compared to 1 by 3 or 1 by 2.8, right? So smaller the sensor, the poorer, it's like a drawing board. The sensor is like the drawing board. So smaller the sensor, the poorer the image quality at for high resolution cameras and low light performance. So it is somewhat directly related. Uh, I have a question. All right. So your answer, the question to your answer, which sensor to use? If you want to be completely neutral, you can take 1 by 3 inch. But if you want your project to have some standard in terms of good camera quality, most premium and good brands, they use 1 by 2.8 inch. Okay, this you can use as a minimum. All right, higher the sensor size is used for low light cameras, so half inch is for used for extremely low light conditions, but you can do a design based on 2.8 and then take it further from there. All right, so when do you use a half inch sensor? The half inch sensor is the two conditions to use. Okay, now think of this way. Now I'm going to draw a box. Okay, so this is 1 by 3 inch. So half inch, how big it will be? 1 by 3 is this. So half will be somewhat bigger. Okay, so 1 by 2 inch. Okay, this is the sensor size of 1 by 2. Okay, now this particular the camera 1, the the light falls on the sensor which is of a certain size. You saw this size, right? This is where the light will fall. Okay, now in this size, if you're using a 2 megapixel camera, okay, well and good. the area for 2 megapixel or 2 million people is, let's say, 0.35, 0.35, let's say 0.35 inch. 1 by 3, if you're not able to keep in mind, let's just keep 0.33 inch. Okay, 2 million people can sit in 0.35 inch of pixels, okay, of area. Now, if I use 2 million people or 2 megapixel or 2 million pixel or 2 million people for our basic understanding, they have more area to sit on. Half inch. Half inch is 0.5 inch, right? So here they have more area. Okay. Now you have to guess, or if you can guess, well and good. But now think of this way: if the camera is 5 megapixel or 4K, is it nice that you will use 2 megapixel also 0.3 inch for 5 megapixel, which is what 5 million people, more than double, they will sit in the same square area. Not practical, right? So when you use high resolution cameras, use bigger sensor sizes. That is one main important criteria. All right. For 2 megapixel, the most commonly used is 1 by 2.8 as the highest I've seen, and also 1 by 2, very okay, we'll come to that, and 1 by 3 inch. This is common 99% of the cameras. Okay. Now the same 2 megapixel, uh, the area is a very special area. It's low light. I need high performance cameras. Then you can go with half inch even for 2 MP. Why should you go for half inch sensor in a 2 megapixel situation is because if you have extremely low light, okay, if you cannot control the lighting, if it is a hotel, you can control the lighting. Imagine this is some kind of remote surveillance, street surveillance. The customer is not going to increase the street light because of your camera, right? He's already installed street poles, he's already installed I mean all the poles and lighting or remote, electricity substations. There he's not going to increase the lighting for your camera. We may not. There you go and propose a low light camera because that is more affordable than increasing the infrastructure. All right, hotels will always have some room for having extra lighting and so on, so it may be acceptable that you use a standard camera for general and most projects. Okay, secondly, why you need higher sensor size if you're using higher megapixel cameras. If your requirement is 5 megapixel, if your requirement is 4K, as per regulation or as per your project requirement, try to incline towards what I've seen is 1 by 1.8, even bigger than 2, or 1 by 1.9 inch, or 1 by 2 inch. So I've seen these good vendors will use these sensors because the resolution is higher. If a vendor is not really particular about the image quality, he just wants to sell, he will try to sell 1 by 2.8 inch itself with 4K. Okay, he will try to reduce the cost. But of course, he will tell you, yeah, it is 4K, but you can imagine 4K resolution, which is what, 8 million pixels, 8 million people will sit within the same area. Of course, the image quality is going to be bad. Okay, so in this tool, it's the same thing. You can see the person is standing at 15 meters, currently 105 pixel per meter. As you reduce the distance, the pixel will increase. You can see his face clarity also becoming better. For example, the door is at 15 meter. So increase the distance. Distance is 15 meter, and you want identification. So identification, pixel should be 250 plus. So 104 is not enough. So you have to increase the focal length. I am going to take 2 megapixel as the common for most of our demonstration because that is what is majority in most projects. So right now, if I use 14 I can use a 2 megapixel camera with half inch sensor and 15 lens. Okay, I'm going to change this also to 1 by 2.8. So if I use 1 by 2.8 inch sensor, I am okay to have 11.5 mm focal length. So well and good. Yeah. So the standard lens 2.8 to 12 will work here in this scenario. Okay, so this is how you do a basic idea. So if someone asks you, okay, hey, I want to make sure that this camera can cover 15 meters and I can see the person's face clearly. So 15 meters, you put the distance and start with 2 megapixel, because if you're not sure, minimum you will find in the market is a 2 megapixel camera, and you can say the lens should be at least 11.5. If he gives you till 12 mm, okay, good. If he gives you up to 15 mm, good. If he's giving you 5 to 50 mm lens, good. You can achieve, because you are going to anyway have 11.5. 5 to 50 includes 11.5. 2.8 to 12 includes 11.5. So that camera is good for this purpose. So another key point, another extra point that you can keep in mind is, if the camera is covering up to 15 mm, maybe let's say I bought a camera A, which is let's say XND XND 6080R. Okay, so when I go to the data sheet, it tells me this camera is 2.8 to 12 mm lens. 2.8 to 12 mm lens. Okay, again let me repeat, 2.8 to 12. That means what? Uh, up to 15 meters, I can use this camera, get identification. All right. So if the door is at 10 meters, no problem. If the door is at 3 meters, no problem. Up to 15 meters, I can guarantee this particular camera, which is up to 12 mm, can give me identification up to 15. So any distance between the door, entrance door can be 6, somewhere it can be 8, somewhere 2 meter, 3 meter, no problem. So you have identified one camera with that lens which can cover up to 15 meters. So you don't have to do for each entrance. Yeah, so that's the point I'm trying to make. You try to do the max one camera with the maximum entrance distance, then everything else is automatically covered. Okay. All right. So this is what we talked about. What is how do you design your project? Identification means what? The first point of entry into any building is identification. Wherever the person is entering for the first time, you've never seen him before, you're going to see him for the first time, that is identification. Everything else, recognition. All right. And you have large open parking spaces, there you can use detection. City surveillance, right? For example, let's say city surveillance, they cannot put a camera every 100 meters, or every, not 100, let's say they cannot put a camera every 20 meter, 30 meter, like a hotel. All right. In the hotel, you have to give recognition for majority of the area. Right? It is okay. In the parking, maybe you will give in the parking you may give detection, but let's say you cannot do a design for a hotel similar to city surveillance. Okay. So in the city surveillance, the most okay, let me take this guy. Yesterday we saw this example where if you do detection, you can cover the entire parking lot with 50 pixels per meter. But if you go further, if you if you demand recognition, I can only cover 1/3 of the parking lot. All right. So a city surveillance customer cannot afford every 30 meters a recognition camera. That is not practical. So they will go ahead and use detection criteria and supplement it with a PTZ camera to do. They will supplement it with a PTZ camera to do identification. So every 200 meters or every 300 meters, they will have a standard camera to do detection. Rest they will have a PTZ to do the identification. Okay, so that's all for yesterday's topic. I think we have covered some additional missing points from yesterday. So now let's go to today's topic. Okay, now networking in CCTV. You personally, I was when I was doing CCTV, and I'm still doing CCTV. I'm also interested in the networking aspects, because we are dealing with IP camera. right? Camera connected to the network. So there is some involvement of networking. But if you go and study CCNA, if you go and study networking, within one or two class, you will get what you need. Rest of the session of CCNA, you may not be, it will not really be involved in the full CCTV aspects. It will be very general. So um, there is no specific course called networking in CCTV. So my objective here is to cover the key points of networking which we come across while working with CCTV. Okay, so this is what I'm covering. So today you are attending CCTV video foundation course as well as you are attending networking foundation course. So you're going to have both the knowledge from this overall course, video foundation course with networking. Okay, in CCTV, what is the camera sending? The camera is streaming or looking at the scene and it is sending the video. Okay, that video should be live view. That means the operator should see what's going on, live view. That video should be recorded, so it has to be stored in the network. That video stored in the network should be used for playback. When there is an incident, they will play back the video. All right, so that data is being used for live view, it is used for recording, and it is used for playback, okay, when there is an incident. Okay, now IP cameras. When you have IP cameras, the camera is of course connected to a network switch. Okay, the operator or the client is also connected to the same network switch. So how the traffic flows? The traffic flows from the cameras to the switch. The switch sends that traffic or routes the traffic to the viewer. Okay, this seems very basic, but let's take it one step at a time as we will cover more details later on. Okay, next, um, when you have recording and viewing, all right, the camera sends the data. Okay, but if you see, it is sending two times the data, one for viewing, one for recording. Okay, before, when you had only viewing, the data is sent just once from the camera. But if there are multiple applications, so viewing and recording, the camera has to send the data twice. Okay, now there are some exceptions here, we will cover that later on, but have a basic idea. The traffic flows from the camera, okay, um, through the switch, and uh, the responsible stream will go for viewing, and the specific responsible stream will go for recording. Okay, three cameras, all of them are sending traffic to the switch. uh, Again, from the switch, it each goes to its own function, one for the viewer, one for the recorder. Okay, now playback. Playback, the camera is sending the video through the switch to the viewer and recorder. The playback is happening from the recorder. When there is an incident, the bandwidth is coming from the recorder. Okay, just keep this point again important. In the networking scope, the camera is sending video stream that is taking some data and bandwidth, and all these words are coming there. Now, the flow from the camera to the client, from the camera to the recorder, that is everybody knows. But some people can get confused. When you do playback, camera is not involved. Camera has already sent the video, camera has already sent it to the recorder. Now recorder is responsible to communicate. So when you do a playback, the recorder is sending the video back through the switch to the viewer, right? If you're playing 60 camera at a time, 60 into 2 megapixel camera, let's say 2 mbps, 120 mbps is being downloaded on the PC. It's like you, when, let's say, if you're familiar with downloading movies online, if you're familiar with downloading some music online, when you download, I mean, you are actually taking it from the source. Same way, So the viewer, the client PC is downloading the video, recorded video from the NVR. Okay, and he will record, and when he's downloading, he will go to full speed that the network can handle. So if it is a 2 megapixel camera, and whatever is the maximum bandwidth it can take, it will take and it will download. Okay, so this you have to keep in mind. Sometimes there are some limitations here. Some some way, for example, some viewing software, when you have a viewing software, you might see some limits. Only 4 by 4 playback is allowed, only 5 by 5 playback is allowed. Why they do that limitation is because they cannot handle a lot of playback load downloading from the recorder, because recorder is now already continuously recording. It is writing on the hard disk, it is working already. On top of that, if you give playback, it has to work again and read. So it is writing and reading, so the recorder will have some stress. So there is a benchmark to how much it can play back. So you will see this when you open the data sheets of any recorders, how much it can write, how much it can output within every second. Okay. So this also you have to keep in mind. Most of the time we skip that part because we don't find it very important during the design stage. Okay, basics of networking. All right. Other than this, a typical schematic, a typical schematic of CCTV, you can have network cameras connected to the switch, and the switches have to be connected with each other with a central switch that is called the core switch. All right, because you have multiple switches, all of them have a home run. They go and connect to a central point. That central point is the core switch. From the core switch, if I connect another switch for the operator, he has access to all the devices, right? So this switch was connected to the operator PC. Done. Then you can have the recorder connected, that is fine. The remaining part, this internet part, router part, just have a look at it. We will see it in the coming slides. All right. Now, network cameras, they will connect directly to the switch. Recorders will connect directly to the switch. If the uh, if the for example, if the camera does not have the option to connect to the switch nearby, so if you see one of the cameras very far, it's almost a kilometer away from the switch area, in that case you will use some kind of converter. Why? Because cat6 cable, this ethernet cable, there is a standard, um, EITI standard, I believe. So, or if, I think the big C related standards, right? That you cannot exceed up to 100 meters. All right. Some vendors can have different things that we are not going to focus on that. We are going to talk about standard. Standard wise, 100 meters, but uh, that 100 meters is including the camera to the your laptop. If you're connecting a cat6 cable, you're using a patch cord, right, to the floor box, including all the patch cords and everything. So um, when we talk generally, we say 90 meters, and the remaining 10 meters we leave it for patch cord connections. Okay, so if you have more than 90 meters, of course you have to use a fiber cable to convert. All right, that word, there is something called media converter. And okay, let's focus on media converter. Media converter, the transmission medium is Ethernet cable. Okay, that medium we have to convert. All right, that's why it's called a media converter. Okay, so the medium of transmission is Ethernet, so I'm going to use a fiber media converter, which will convert that medium of transmission from Ethernet to fiber. All right, and fiber, you have you can see how it looks. This is Ethernet and this is fiber. Fiber uses glass. You can go for at least 2 kilometers and more, up to 20 or 40 kilometers, depends on the fiber cable spec. Okay, so that is for separate section. So you got the idea. So you can use different medium converters. You don't have to only look at fiber. That medium you can use wireless. So that medium of communication, you can use any. as per the new technology. Tomorrow you might have some other technology, no problem. You can use the medium as coax cable, Ethernet over coax. Only the medium is being converted. We are not converting back to analog or anything. All right. So just use that word medium. That medium conversion can be anything as long as it reaches the switch back. So when you convert the medium, you have to convert it back. You have to reconvert. Okay, converter, and then you reconvert back at the end, and then you connect it to the switch. All right. So a camera is responsible for sending video, but let's say when you go to a restaurant, you go as a family, each of you will order one dish, right? You might like, let's say you might go for the mixed grill, or you might go for biryani, or you might go for different dish or salad or so on. Same way, if you're on a diet, let's say you're going on a salad. Same way for a camera, there are a couple of people who are going to access the camera. Okay, the people that will access the camera is first one, client PC, operator PC. He wants to see live view. Second guy is a recorder. Remote location, optional. Remote PC, remote viewing, whatever. Could be anything. Minimum there is two. Live view, you want to see what's happening. The operator wants to see what's happening, and recording. The live view guy is this person. When he goes to the restaurant, he will say he's just looking. He's not eating. Okay, he will say show me everything. Same way, you will see full resolution. The live view operator will see full resolution and full frame rate. If it is streaming 25 frames, 25 frames. Full resolution, done. But the recorder, he's like, okay, I have to eat. My stomach is only so much size. I cannot eat everything on the menu. He will say, okay, just give me 2 megapixel, which is your best food, and but give me portion only 10 frames. Don't give me full portion. Give me only 10 frames. Okay, so now he's demanding slightly different. The remote guy who's not on the place, he's taking a parcel or something. He's like, okay, I cannot carry everything. Just give me half megapixel, 1 megapixel, or maybe 0.5 megapixel. Okay, and maybe 5 frames. All right. So this is how the CCTV system also works. The operator client is not going to record, so he's like, I don't care. Show me everything. Anyway, I'm not recording. I'll just see and drop it, and I will discard. Right. But the recorder has to store it, so there is storage involved. He's like, I have only so much hard disk, so I want to I want 2 megapixel, but give me less frames. I don't need all the frames, and it's not that important. I need the core of the data, not every single bit of the data. So remote viewing will say, okay, just give me, again, over the internet, I don't have so much bandwidth, I cannot carry so much of information. Just give me a half megapixel. I will have an idea what's going on, right? So the camera has to send, or has to, whoever is the restaurant guy, he has to make three different food, one for live view, one for recording, and one for takeaway. Same way, for live view he will send probably 30 frames. For recording, maybe he will send 10 frames, and for remote viewing he will send another 15 frames or half megapixel and so on. Okay, so who's doing this cooking? The camera is doing the cooking. All right. So the camera, if the person is, if the camera is not powerful enough, is not capable enough, the camera will tell you, or three profiles, we call it profiles. The camera will tell you, I cannot handle to make for three people. I can only handle two. I can only handle one. Okay, this is again where the price goes down. Some low cost vendors, they cannot handle more than two. All right. If they even two, they will say, I cannot handle uh, I I cannot handle 2 megapixel two times. Just one time I can give 2 megapixel. Another dish I can only make a salad. Okay, I can only give half megapixel. So that is where you have to keep in mind whether the camera is capable or not. All right. So most good vendors, they know how the CCTV system works in a real environment. They know that customer will use full resolution for recording and frame rate for live view, and he will record full resolution but little or a reduced frame rate for recording. So most good vendors, they will give you at least two separate same resolution and different frame rate, and some vendors will give you three, some will give you more than that. So we have, if you take Hanwha, we have certain series which can give you 10 profiles. We have most of the series can give you 6 streams from Hanwha. Okay, some can give you 20 streams, but I have also worked with other companies where we cannot give more than two. So my experience with Hanwha and previous and other companies, so there are brands which cannot give more than two also. All right, some cannot give more than three, and the second one, if you are taking a 4K camera, 25 frames, they cannot give another 4K. They can only give 2 mega 20 frames or 25 frames or 10 frames. So because the processor of the camera cannot handle. Anyway, your takeaway here is, do you need live view 4K 25 frames? Do you need 4K again recording at 10 frames? Make sure camera is capable of doing dual stream. If the camera is not capable, you can still buy the camera, but you cannot demand from the camera two different menu. You have to say, okay, I will live view 4K 25 frames. I will also record 4K because that's the maximum capability of the camera. So the storage might slightly higher. So you got the idea. So if you're compromising on the camera, you have to again compromise on the storage and give more storage for that project. And for every future expansion, you will have to end up paying more storage. Okay. So you have to keep only this point in mind. Okay. For for some reason you have no option, you can go for it, but um, hard disk is also expensive, yeah. So cameras are fine, but at the end of the day, you're recording not one camera, a 500 camera project and 30 days or 180 days. Even if you say, okay, the camera is very cheap, but it can only give 4K 25 and not 10, that means you have to record full time 25. You will end up paying more in the hard disk. Okay, and okay, so let's see other points in networking. Okay, there are a few questions. Um, Regarding registration, you have to send me an email. Chat was not ideal. What about dead zones? Okay, we'll cover that later. Oh, identification with box DB120. Okay, uh, for identification, you have to use varifocal lens for sure, because you don't know where the entrance is, and there is a chance you need to zoom in. So you need varifocal lens. Yeah, that's fine. You need good WDR if you have sunlight. Recognition and observation and other areas, you may use fixed lens. It is up to you. You can use fixed lens. In my opinion, I would always suggest a varifocal lens because that's the best. But if cost is there, then of course fixed lens can do the job. Okay. Next is the reduced frame rate, then video quality is good or bad? Video quality is resolution 2 megapixel. Okay, you are not reducing the resolution, but frame rates you're reducing. How much of frames per scene you're reducing? Now we will see about how the frame rate has an impact. I'm going to come to that, so you will get a better idea. Okay, then bandwidth. Camera is sending video, right? Camera is sending video. Now, in order to send video, that video data is actually what is a representation of the scene. So if the scene is very complex, the data also will be very complex. Okay. So for example, if the complex background, see, you see this tunnel, there is a lot of pillars, a lot of details in the scene. So of course, that will require slightly higher bandwidth. If the scene is very basic, For example, at the bottom you can see this tunnel again. Um, Cars are passing through, but not it's not a busy. If it is not busy highway, not a busy area where few cars are passing through, then the bandwidth will be lower. That is one. Second reason why sometimes bandwidth is higher: noisy video. The light is not there. That means the camera is working very hard to capture everything in the scene. A lot of noise is generated. Okay, again we will see how noise is generated. I'm going to cover that either today or tomorrow. I will be covering that, so you'll get a better idea how noise is generated. So if the video is not crisp and clear, you will have more bandwidth. So keep this in mind. Sometimes you are trying to have a save cost on the lighting, but if the camera is struggling to get video, it will jump the bandwidth by twice, and your storage for that area will be double those areas, especially outdoor areas in night time. So how do we compensate this? Use cameras with IR lighting. Many government regulations, they say outdoor cameras should have IR. That is good because the area will be clear, so less bandwidth will be used. Then dynamic video, static video. Again, the same thing. In the scene is having a lot of details, metro stations, public city surveillance, different types of car keep on coming. That will have more bandwidth. So when you're doing a design for a hotel, and when you're doing a design for another type of project, which is a metro or an airport, you have to keep this risk factor that it's not the same level of storage that you'll end up. You cannot do a storage calculation called average scene. When you do storage calculation, you have to give some inputs to the camera. What type of scene? So uh, you have to keep that in mind. Okay. Again, one more point: you don't have to worry about every scene in the project. A hotel, if you take a hotel for example, the entrance will be busy. It's okay, but the same hotel is having parking area. The same hotel is having back house area. The same hotel is having storeroom. Same hotel is having corridors. In the night time hotel, not many people are moving around. So if you take the project as a whole, you don't have to worry about few camera in the entrance will have high scene, high activity. That's not a big deal. It will just compensate because it's average in the scene. But if your entire project is only airport, if the entire project is only street surveillance, then there is no idle camera to compensate. So there you have to keep this risk and consider storage accordingly. Okay, so that's the point here. Next is okay. Let's see. All right. I have one more point to explain. Let me explain that quickly. Um, yeah, add one camera, two camera. All right. What do you see on my monitor? You're seeing a camera sending a video, high resolution and low resolution. You can also call it high profile, low profile. It is sending to the recorder and to the viewer. Recorder is going to record the full resolution and it's okay. The viewer, the operator, he has two types of viewing. The operator, the viewer, has two types of viewing. I think this most of you know by now based on your experience. So if you take for example, I'm now on this one. Okay. When the operator is viewing the camera in a full screen, he needs full resolution. If it is 2 megapixel, he wants full 2 megapixel. But when the operator looks at the camera in a 360 a view like this. Okay, in this case, you don't have to give 2 megapixel into 35 cameras. During this time, the operator only needs half megapixel. Okay, he's switching the view. He's saying I'm only viewing one part of the screen, and this screen size, okay, this screen is, I have a full HD monitor, and the screen size, okay, I will read it out. It says this particular block, right? It's only 336 pixel by 176. So the distance, this distance, oh, this, yeah, okay. The distance here is only 336 pixels, okay. And the height is 176 pixels. So technically speaking, this is only 336, this view. So the operator client will intelligently tell the camera, see, I'm only looking at 336 pixels. If you're giving me 2000 pixels, 2 megapixel, I don't need to show it, it's so small area. So it will ask the camera, do you have another profile, can you give me something else? So it will be light on my PC, so my CPU will still be less than 20% usage, right? I don't have to use more CPU to see so many 2 megapixel videos. So the viewer, there are two criteria for the viewer. It depends on how much he is viewing. If he's viewing 4 cameras, he will see all of them as 2 mega or all of them as 5 mega. But if he's viewing multiple cameras, the viewer cannot, the PC may not be able to handle that much load. The PC will tell the camera, give me another resolution. Okay, so what is your takeaway here? When you have a camera for your project, you need three functions from the camera. One, viewing. Under viewing, there are two types: high resolution viewing and low resolution. And recording can be again high resolution, but maybe 10 frames instead of 25 frames. So the camera should be capable of giving you high resolution and another low resolution and another profile with a different frame rate. Okay, so this is an ideal camera in today's market, today's scenario. A camera should be capable of giving, this is the word, three indi, independent streams minimum, files minimum. Okay, at least two streams should be native or full resolution. Why? Because you will do live view full resolution, and there is a chance you will record full resolution on a different frame rate or different codec. So the next, okay, let's take a break then, and we will catch up. So I will just go through some questions. I hope my audio is okay now. Is gone. Yeah, okay, it is fine now. Okay, okay. All right, so we've reached the 1 hour mark. So let's take the break and then we'll continue. Okay, thanks for the
What is there? There's a mute here? No.
Okay, so I have managed to connect to another network, so my sound should not have any issue going forward. So hope you had a short break. Let's continue. Thanks for letting me know. Yeah, it was on mute, so I just unmuted. All right, so let's continue with the topics today. Certain questions. There are one or two questions which I will answer at the end of this session today. Okay, so let's proceed. Let's see. Yeah, everything looks good. Now, codec. What is codec? Okay, coding, decoding. That is codec, right? And there are different types of codec that we will see. But where the coding and encoding is happening in the CCTV system, right? Um, it's- okay, so where the codec and encoding is happening. From the picture, it is straightforward. If you use analog camera, the old technology, the encoding is happening on the DVR or the recorder. When you use IP camera, all the load, all the compression, all the coding and decoding happens on the camera side itself. All right. So actually, this is a big difference when we transition from analog to IP. When the codec or when the decode, what is coding and decoding? Camera, okay, camera sends a video. That video is converted to digital format, like JPEG and PNG image or RAW image. That is a digital format. That digital format is conversion. That media conversion is happening, or data conversion is happening in the recorder, in the analog system. Okay, and then when you do live view and playback, when you're doing live view, again it has to be decoded. Okay, whatever ones and 101010 digital format that is written has to be decoded again. So again, the PC, the operating PC, computer, laptop, workstation, i7 PC or i5 PC has to decode that data real time. So when you see the video on the screen, a lot of process happens at the background. The data is being coded and decoded at this real time. Okay, real time is at the same time. IP camera, the coding is happening on the camera, all the compression and everything happens on the camera, and it sends the data. The coded data is sent to the recorder. The recorder helps with the decoding. I mean, not helps with the decoding. Recorder sends the data to the PC. If you have operator PC, the PC decodes it for at the monitor side. Okay. If you have monitor connected directly behind the NVR, that means that NVR is doing decoding also. It is coding and writing on the hard disk. I mean, so I mean, the coding is if it is IP, it is done on the camera, so it is recording. That's fine. Whatever is coded is being recorded. But the decoding, if you have a monitor connected directly to the NVR, it's happening by the NVR. Okay. Here, if you buy a PC, the PC is doing decoding. So the word client PC is also in a technical word called decoder. Okay, in CCTV we use words called decoders. Decoders are basically client operating workstations. Okay, if you can have Linux decoder, you can have Windows decoder with any kind of viewing software. That's a decoder. Okay, all right. Now there are different codecs. um, Let me go very quickly on this topic. By today, a couple of years back, we had to educate, but today almost every camera is H.265, so it's okay. It looks good now. But just remember, H.265 today is common, but when was it introduced? 2013, right? So many vendors adopted much earlier. So we adopted around 2016 to 17 timeframe. Many vendors adopted in 2019 and 20 timeframe. Some of them, I think almost everyone adopted by 2019 and 20. So how soon the vendor adopts, that depends on the vendor. Okay, but why did it take time to adopt? That's what we will see now. H.264, H.265, these are compression or video encoding technology. There is H.264 plus, H.265 plus. This is something, this is on top of H.265, on top of H.264. Okay, it's not something new. That is not, okay, that is proprietary to CCTV. Okay, JPEG, you know JPEG, it is existing globally. H.264 globally. These are global international standards. H.265 global international standard. On top of that, we can do additional compression because we are CCTV company. We want to compress more for storage, so less recording space is required, less bandwidth is required, cost is reduced, and so on. That is different. So we can call different words: zip stream, Y stream, H.265 plus. You can smart compression. You can use different words for it because it's by the vendor CCTV field. Okay, but vendor cannot go and say, I don't want to call it H.264, I want to call it H.269. I cannot do that. Okay, these are international standards. On top of that, you can do whatever you want and call it Y stream, zip stream. Some vendors, they trick you by calling H.265 plus, but that is proprietary to the vendor or proprietary to CCTV technology. It is not a global standard. Okay, don't think, oh, that's a new global standard. That is not. Okay, so here we have H.264, H.265, H.265 plus. Okay, sorry, H.265 is the latest compression technology. How is it good? It is good because it can compress the same amount of data and use less storage. So for example, for example, couple of years back when I started in 2009, we used MPEG 4, MPEG 4 cameras. Okay, that time half megapixel, 800 by 600 or 704 by 576, but I'll round it up, was taking around 2 or 1.9 Mbps. All right, full frame. Then there was another couple of years back, another came that is um, 2 megapixel, also takes roughly 2 Mbps, 2.0 Mbps, H.264 codec. Okay, then came H.265, around 4 megapixel, like, also takes around 2 Mbps. How is this possible? 2 Mbps. Oh, not allowing me there. Okay, so higher the resolution, but I'm using the same amount of fuel or bandwidth. Did you get the point? Okay, so the bandwidth or the fuel requirement by the camera is the same, but resolution has from 0.5 MP, actually 0.5 MP, this has more than doubled, right? Almost 4 times. This is almost 2 times. You can even take 5 mega, roughly 2 Mbps. You can almost get, okay? So with H.265. So if you see, resolution has doubled and more than doubled, but the bandwidth is still same. Who's responsible? Codec. Okay. Codec means what? You will see in this very short representation. A camera is looking at the video. There is a car, there is a scene, night scene, car is moving, there are trees, parked cars here and there. Okay, it is capturing 25 frames or 30 frames. You can take any example, 25 or 30. Every frame, first frame, this frame 1, the car is here. Frame 2, car is moved slightly ahead. Okay, now remember, the camera is supposed to take, you are saying 2 megapixel, 25 frames per second. Okay, remember second, 1 second, 25 fps. So this is just 2 frames. So the third frame, maybe car went little more ahead, so on. Okay, now what the camera does, if it sends frame 1, frame 2, full picture, there is not much, I mean, it will require a lot of bandwidth. But if for example, let me take a note. Here we go. So here, this area, other than the car moving, rest of the area is idle. There is no changes. Okay, this area, all this area is no change, right? So this is what the codec is supposed to do. Look at the scene, say everything is okay. Okay, the same data is being sent again and again. I'm go- the camera will decide I'm not going to send it again. I'm going to send only the changes in the scene. Okay, so here we go. Back to erase all. So this is the job of codec. When you apply a codec H.264 or 5, it's sending only the changes. So frame 1 full frame, frame 2 called, it's also called partial frame or P frame. The frame 1 is called I frame. It's only the difference in the scene. The remaining area where the car is parked and the rest of the streets, it's the same data, so it will not send it. So you will save bandwidth. That's why storage is less. That's why when I have a better codec, I can send more data with the same bandwidth, because the codec, what it does, it is doing this calculation. It is trying and analyzing the scene real time and checking, okay, where all I can reduce, where all I can reduce, and it is reducing and sending. H.265 does more calculations. H.264 will calculate the car in, let's say, in a direction like this. Maybe H.264 can calculate 6 directions. Wherever the car goes, it will say it's the same car, so I will not send the data. But H.265 can calculate more than 30 directions. If H.264 is 6 to 7 direction, it can identify the same car. H.265 can identify the same car in 30 different directions. So more calculation H.265 can do and identify and reduce the storage. If the car is went reverse, okay, it knows, oh, it's the same car, and again it will send only the difference. If the car went slightly sideways, it just knows it's the same data. And according to the camera, it need not be a car, it's that data here in this block. The same color if it is somewhere else, same data value if it is somewhere else, it will not send it. Okay, so you hope you got the idea. So the H.265 is more processor intensive. It takes more CPU to do more calculations real time and compress the data more. That's why H.265 cameras are a new series of camera. There, it's not like a upgrade. You cannot you cannot download an update like Windows Update and make the camera H.265. That is not how it is done. A CCTV camera, the processor has to work more than 5 times more to process the same image. So I don't think any vendor designed a CPU which is 5 times powerful in the future. That's why many vendors took a lot of time to adapt. Okay, so I know many big brands just adapted in 2019 to 20 after 7 years of H.265. Okay, so this is something we were developing a chipset in 2016, so we already adopted at that time itself. Okay, so other brands had to develop a new chipset, so it took more time for them. All right, other brands had to wait for, if the brands are not developing their own chipset, they have to wait for someone to develop, and then they will adopt in their camera. Okay, so H.265, that is the purpose, to reduce the storage. H.265 does more calculations. Okay, now we will see H.265 plus, H.264 plus, all these fancy words. These are very, very powerful technology in CCTV. It is applied on top. Okay, so every vendor has their own proprietary name. We call it Ystream. Some vendor call it Zipstream. Some vendor call it smart compression and other words for it. That is applied on top of H.264. Some vendors don't know what to call. Maybe they just left it H.264 plus or H.265 plus. So for us, we say H.265 plus that technology that is called Ystream. All right. So here we go. Let's see what is the meaning of Ystream. Okay, I will start from scratch. So currently, I have a 2 megapixel camera now. It's look, the live view is not that active, and Just a second, I have some questions. Yeah, just, okay. 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 Okay, so we have a 2 megapixel camera just for a short demonstration purpose. And let me see. Okay, let's go to information. Currently, it is streaming around 1 Mbps for 2 megapixel. Scene is not active, right? So 2 megapixel, 1 Mbps. Okay, good enough. Let me refresh. Around still 989 kbps or 1 Mbps. Okay, now I'm going to activate Wisenet settings, video, Wisenet. What is this? I will start with high for demonstration purpose. Okay. Go back to live and click. Okay. It will refresh. Give it some time. So what is Ystream? Ystream is a technology used mostly and only in CCTV. Okay, this particular technology. The idea of this Ystream is it developed this way because today we have a lot of CCTV cameras, right? We have a lot of cameras everywhere, but but you are not I mean, the scene, okay, take an example of a hotel. A hotel scene, for security purpose, you will have 200, 300 cameras, but there is only two or three entrances. If you cover the entrances, maybe 10 cameras is enough and cover the entrance and exit. But for security purpose, you have to put 200 to 3 or 300 cameras. Every corner, every floor, every staircase, or every area you have to put. Okay, so there is a chance that there is not much activity happening there, but for sake of security, you have a camera, right? You're recording the camera. Maybe if you take Dubai regulation, you have to record 24 hours. You cannot do motion recording, motion only recording. You have to record 24 hours. So there is no value in the data where there is no activity. So that's why these technologies came. They will observe the scene further, and if the scene is not really active, it will go and compress the iframe further. It will go and engineer that iframe. It will try to reduce the size of the iframe. Okay, so that is the compression technologies. How good they do it, how efficiently they do it, that depends on the vendor. And if, let's say, if someone is walking in the scene, automatically it will stop that extra compression and it will use the normal bandwidth. Okay, how quickly it can do. For example, if someone is walking here, the camera will only increase bandwidth in that particular area, not the entire scene. So that depends on vendor to vendor, how efficiently they can do. But overall, the idea is to engineer that iframe to reduce the bandwidth. Okay. Now, this is Ystream level 1, the standard level. Currently, it took 665 now. So roughly half, 40 to 50% reduction you can expect with the Ystream. On top of this, there are additional methods. If the scene is surely idle, and you know that for a fact, there is an option called dynamic GOV, dynamic frame. Okay. What is dynamic GOV? Okay. Now back to this concept. Back to this. Okay. Now imagine when the camera is looking at the scene, every second, SEC, every second, it has to send 30 frames. Okay. Imagine yourself within 1 second, how much are you moving your body or your hands? Not much, right? So every second, if it has to take 30 frame, 30 pictures, most of the scene, other than the car, most of the scene is the same. It's idle, right? Every second. Okay, so that's why you're doing this concept I frame, P frame. All right, 1 second, in 1 second, it will send maybe one iframe. Sorry, yeah, one iframe, and I think better to write it. So within 1 second, iframe, it will send just one, p frame, it will send 24. Because within 1 second, not much change is expected. Okay, so Y-stream level 1, you are attacking the iframe, you are compressing the iframe. There is another option where you can, the vendors also do this. This is called additional or advanced, they might call advanced stream, advanced setting, but the concept is the same. They will increase the interval of iframe or p frame. So let's keep it at the maximum to for demonstration purpose. So I changed now iframe interval. Instead of sending within 1 second uh, iframe 1 and 24, I'm saying send, if the scene is idle, send after every 8 seconds or after every 2 seconds or after 5 seconds. Send just one iframe, and remaining, let's say in 8 seconds, there are 259, remaining 472, send only p frame. So, or remaining 400, let's say, send p frame. So increase the interval size. Don't keep sending iframe every second, send after 5 seconds, because the scene is simply not very active. The scene is simply idle. Back house area, staircases. If you know for a fact, schools, after the school is closed, it's going to be idle. Maybe one or two area people will clean for some time and they will leave. But 90% when the school is closed, it's going to be idle, right? So that is the job of this technology. Now, if you observe this particular camera, it will stream much lower. So it'll look at the scene, it'll observe the scene, it will check everything. Let me go back and double check the settings. Settings, video profile. Okay, I need to enable this. Sorry. Let me go ahead and enable this. Make it 300, 400. Okay. Okay. I need to disable this also. Okay. Now let's go back to the live view. Okay. Click on information. Give it some time. Check for the live view now. Give it some time. It will update. So now the camera, if the scene is idle, it will now send iframe after 5 to 10 seconds. You can also tell the camera, don't give me full 10 frames, 25 frames, give me 1 frame, 2 frame. You can even customize that. So based on that, the camera will send the data. Okay. Um, okay. There is someone moving. So, so when the someone is moving, it will not do that. When the scene is idle, it will apply that again. Okay, so there is a question: should I use Y stream level low, high, or medium? So if you know for a fact that this is a school and this, you can use medium or high. But if you're not sure, you can always use level medium. What is the objective of level low, medium, high? Think of it this way: low means you're going to say 10% of the time the scene is idle. That means 24 hours, roughly 3 hours, the property will have very less activity. Medium, roughly 6 hours, the project will be less active. 6 hours they'll be sleeping, not much active. Medium to high, or almost 12 hours, like schools, 12 hours closed, 12 hours open. Offices, 12 hours closed, 12 hours open. Most of the half of the day they are going to be idle. So this is the mode: low, medium, and high. Okay, And you can do the setting using another tool. You don't have to do each camera by camera. There is a different tool where you can push the settings bulk to all the camera at the same time. Okay, all right, all right. Next is camera types. What is camera type? Uh, every project, every application requires a slightly different model of camera. We saw yesterday you have indoor camera, plastic housing. We saw yesterday there are outdoor cameras with metal housing. Okay, they may have the same resolution, they may have the same lens, but the construction shape will be different because the environment where the camera is being set is different. Again, we saw yesterday some cameras might have a higher focal length, 5 to 50 mm instead of 3 to 10. Okay, but it might look the same. It might look like a dome camera, but the lens can be different. So there is not one camera and you can say it is suitable for everything. It may not be the case. Okay, you can have a dome camera, you can have a bullet camera. Bullet camera is what? It is an outdoor camera. It has got a sunshade, built-in lens, built-in IR LED, built-in wall mount, everything included. IP housing, external housing, everything is included. So it's an all-in-one camera, but it's still bullet camera. Can you use it indoor? You can, but it will look bad because it's a slightly bulkier camera compared to a small dome camera, right? Imagine your ceiling, you have all these nice light fittings. Do you see any screw in any of the light fittings? No. They're all flush mounted, they're all recessed mounted, so it looks aesthetically good. So imagine your ceiling having all bullet camera, it will look really bad, right? So every application is slightly different, but the component can be same. The sensor, image, everything might be same, but shapes will be different. Okay, you can also have bullet camera with long range for perimeter areas. You can have, if you're not sure what lens is required, you will use a box camera with a special lens from maybe from the vendor or from Fujinon or Canon. You will buy a bigger lens. For mounting on the car, vehicles, you might have a special rugged lens camera. So this lens here, the glass here, the bubble will be more high resistant to vandalism, right? Because it's used on the cars. People can touch it, people can scratch it, right? So it's not, I mean, it's not on the ceiling means you need a ladder to go and climb. That is okay, but this one is accessible by the person. He can touch the car, right? So if it is inside the car, so there will be more protection for the glass, more protection for water and other things. Lift, small cameras inside lift, small space, because inside the lift everybody knows the lift is not going to be 100 meters wide. Everyone knows the lift is going to be 2 by 3 or 2 by 2, 1 by 1. It's some specific size, maximum that much only, right? So there you can use a fixed lens with a wide angle. You don't need to do adjustable lenses for lift. Offshore area you can use marine stainless steel camera. Low light areas you can use low light camera. Pinhole cameras inside the ATMs, inside the machine. Okay, there is no ceiling, there is no wall mount, it is only one small hole. Okay, think of this way. How do you imagine a pinhole camera? In your laptop you have a camera, right? That's a pinhole camera. That's a small camera lens connected to the camera body. Body is somewhere else in the CPU, probably in the motherboard. There is another chip for the camera. Okay, so only the lens you can see, but rest of the component is somewhere else. So that's a pinhole camera. Fisheye camera, we will see that later. These are 360-degree cameras. Then there are other cameras with more than one lens, multi-sensor, two sensor camera, four sensor camera. We will see that also. These are panoramic cameras. Panoramic cameras, four sensor cameras. What is the objective of four sensor? You will have only one cable, but you can look four direction. Each camera separately you can adjust. Each camera separate lens. But because it's a street, you don't need to pull four cables. One cable is enough. And if you use any VMS, they will only ask for one license. So it is beneficial in many ways. So certain locations, panoramic cameras is good. Aesthetically, only one body instead of four camera looking here and there. You have one, it looks like one camera, but four lenses. Then there are two sensor cameras. This is also there. Then what else? Okay. Okay. Next is categorization. Vendors will categorize cameras based on uh, functionality. Okay. Imagine the same thing with your laptops. Okay, or your mobile phones. You have mobile phone with two cameras, or sometimes you have mobile phones with three cameras, or you have if you take Samsung, you have a pen to write on the on the mobile phone. Then you have tab. It looks bigger, it's a tablet. So you have different shapes and sizes for different applications. Okay, functionality wise, bigger and more processor is required for some types of cameras or some types of phones, and lesser required for lesser range of phones. If the functionality is reduced, the processor is less required. Same way in the CCTV, if the functionality is more, you need a bigger processor. So different camera series would be used. Okay. Now, back in the day, if you take 5 years back, vendor or supplier or manufacturer, they would split the series based on resolution, because before 4 years, 5 to 6 years back, if you want to use a 4K camera, they need to use a bigger processor. Okay, that time having a 4K was requiring higher processor. But today that is 4K or 8K cameras, 8 mega cameras. Yes, today today that is not the case. Okay, resolution you can find today you can find a low cost camera, very basic camera with 4K resolution, but it will not have analytics. It will not have WDR. That depends on the CPU. Okay, back then, if you buy a 4K camera, it's like buying Lexus, or people know everything is included. They think everything is included. That mindset is a problem today. It's your risk today, because there are vendors who manipulate that. There are vendors who misuse your belief, thinking I bought a 4K camera, so it is better than someone else's 2 megapixel camera. Okay, resolution is good, but there are many ways that a certain vendor can play with you, right? Um, so that camera may not be suitable because it doesn't have WDR. Maybe that camera, the sensor, it will not probably have analytics. Okay, maybe you need SD card recording and some other functionalities, it may not have. Okay, you don't have to just look at resolution. That's the point number one. Second thing, also I have noticed recently some vendors saying they are 4K, but they're using 2 megapixel lens. The sensor is 4K, but the lens is 2 mega. You remember yesterday I told you, even the lens should be spec'd for 4K. All right, it's quite expensive when you go for 4K lenses. So that's where they play with you. So just keep in mind, don't blindly believe a higher resolution will solve everything else. No, you have to check each point separately. And it's no longer a resolution. differentiation. It's purely analytics, the processor capability to do WDR, processor capability to do much more than just resolution. Okay, so we have products, we are categorizing our products based on how many analytics you can achieve, because analytics is running on the camera and it is doing motion, temper, some person detection and other things real time. So we are trying to split the camera based on that. Okay, and also we have I mean, for example, we have four series. We'll take, I think, our example. Okay, I have here Q series, X series, P series, T series. Q series also we have 4K camera, X series also 4K camera we have, P also we have 4K, so on. But the difference is Q series will have around 6 analytics. In the future, it will have 8 analytics. X series will have 15 analytics. P series will have more than 15 analytics. So analytics is one of the differences that can be. So every vendor may have different method, but remember, most of them cannot deny performance or analytics that will require you to split the category. Okay, so every vendor may have a 4K resolution. Okay, for example, Q series, you can have 4K, fine, no problem. They will have special lenses for that. And X series, we might have more options for 4K. We might have another low light series of 4K. We might have PTZ lenses of 4K. So we'll have probably more flexible models in 4K, stainless steel, transportation camera, long range PTZ camera, special long range IR cameras. We will have that in the X series. But the most commonly used, I need just a basic dome camera, 20-meter, 30-meter IR, you will find in Q series. Okay, so if I need 50-meter IR, 90-meter IR, you'll find in X. 500 meters IR, you need in X. I need artificial intelligence that requires more CPU, you'll find in P series. You will find AI also in X series. So roughly speaking, the series today is purely driven by the processor, how much of CPU is used. 6 analytics, X series 15 analytics, more than 15 analytics, customized analytics you'll find in P series. So more CPU is used there. All right. So roughly you will see that multi-sensor camera, more than one sensor is used. So more CPU is used. So you'll find that in the P series, right? So if you don't need more analytics, you don't need to worry about having more CPU. So let's say you're buying your camera for just checking email and going to Teams. You don't need i7, right? You don't need i7 to do, or you don't need to run AutoCAD, you don't need to run design tool, you don't need to do video conversion, video editing, you don't need to worry about high processor. Same way, if a customer is looking for basic CCTV, not much analytics, not much long range and processing, not multi-sensor, he can just stick with lower end series, no problem. Okay, but just remember, a P series can be 2 megapixel, it can have 15 analytics. A Q series can have 4 mega, or a Q series you can have a 5 megapixel, but P series will have more analytics. Still it is 2 mega, maybe it's a 2 mega. Okay, so price can be more. All right, so don't assume that a vendor. Okay, so let's say I have a P series AI camera, artificial intelligence camera, 2 megapixel. I have a Q series 5 megapixel. So this guy will have more than 15 plus analytics. This guy will have 6 analytics. So don't assume just because my Q series or I bought a camera which is 5 mega, it is better than P series. Don't assume that. That's all. Okay. Look for the whole picture. You might even have Q4K, no problem. But maybe this is more expensive. Why? It has other functions. Okay, so keep that in mind. There is a widespread way of many vendors trying to tell you this is better, that is better, only focusing on resolution. And that also they might manipulate further, but just keep in mind that is not the only criteria for higher spec camera. Okay, so we will see these topics later. So I will cover some one more lighter topic today. Okay, gain and noise. Let's just do this part and we will be done for the day. Gain and noise. What is gain? Gain. Gain simple. If you cannot hear me well, you will increase the volume. Same way, if your camera cannot see the video properly, it looks very dark, it looks very black. I cannot see what's happening. I don't know who's standing there. The image is very dark. You will turn on the lights, right? So camera, what it does, it will increase the gain, so the image will become brighter. But the challenge is, you see the pixelation or not pixelation, you will see this graining, right? You see it's dots, noise. This is noise in the scene. Because how does it happen? Okay, so imagine there is someone talking behind me. When you increase the volume, even if someone is talking behind me, you can hear his sound, right? So that is extra sound that also will get amplified. Okay, so same way in the CCTV, when you increase the gain beyond a certain level, even the small noise will get amplified. Okay, small uh, noise in the scene will get amplified. That's why you see this graining. But what is the good side? The image is now brighter, more clearer. Okay, so now to compensate this, there is one more technology called noise reduction. Okay, noise reduction means it will analyze the scene and it will look for the noise and it will reduce that noise. That is noise reduction technology. All right, so when you do gain, it's not always the best because you are also going to increase the noise. So when you do noise, when you have noise reduction technology. But the challenge with noise reduction technology is when you keep on doing noise reduction, when you process the video too much, okay, you will see issue like this called ghosting. When you do a lot of noise reduction in low light, you cannot, can you see one guy walking through the door? Again, let me show the video. So there is a guy walking and you can't really see him. Okay, you can see like two, three people walking at near the door side. So when you see here, you see there is one border. You can see there is one border here, and then there is another guy here. It's called ghosting. So this is the thing with CCTV. When some people go and go to the site, they increase everything: noise reduction high, gain high, image brightness high, everything high. Then image becomes very bad. Why? Because it's like a triangle. If you change one setting, other two settings will get affected. So you have to look at a triangle to actually understand. So it's like a triangle. So you adjust one side, these two sides will become smaller. If you adjust the second side, these two sides will become smaller and get affected. So that is the thing. Everything affects everything else. So this we have to understand in CCTV. Again, that's why you have SI companies, you have engineers there to help and fine tune the settings of the camera. Okay, when you increase the gain, image becomes bright. Okay, scene is not very bright, so it is okay, but it also affects the image quality. All right, so here let me show you. I think before we close, let's have a quick look. Let me go back to the video and the camera setup. Okay, now watch this video. I'm going to the camera settings. I'm going to the advanced settings, and I'm going to show you this scene looks bright, right? On the side, everything looks fine. I'm going to adjust the first. I'm going to adjust the f-stop. Okay, what is f-stop? Okay, let's just wait for the video. Adjust the f-stop. I'm changing it to manual. Okay, what is f-stop? You know the opening and closing of the eye of the camera. It's called the iris. It will it is done automatically. Most of the time it is done 99, I mean 100% of the time it is done automatically. That's why it's called auto iris, because there is a motor, it's called a DC motor, direct current motor. That motor will open and close the iris depending on the amount of light. Just like in our human eye, when the scene is too bright, we automatically close our eyes, and then it will adjust automatically the amount of light going through, and then we can see better. So same way, this iris opening and closing is done automatically. Okay, I'm going to make it manual, and I am also, oops, sorry, iris. I am going to change it, but okay, manual, and there is something here called AGC, automatic gain control. If the camera thinks there is no light, automatically it will increase the lighting. Okay, right now it is high. I'm going to switch off the gain control, and I'm going to change the iris. Okay, just see the iris now. Iris is I increase the f-stop 10.8. That means when you increase, the amount of light going in will be less. It is inversely proportional, right? I think you are aware of this. You're aware of this light. This is that f-stop. Higher the number, smaller the opening. Smaller the number, bigger the opening. Okay, smaller the number, bigger the opening. So I have manually changed. Uh, okay, I'm going to first change the gain control. I'm going to switch off the gain, and I'm going to change the f-stop. See the scene on the right side. When I increase the f-stop, when I made the iris opening very small, it is now black. When I increase the f-stop, or when I reduce the f-stop, it becomes brighter. All right, that is f-stop. Now I'm going to increase f-stop again. It is now as good as dark. Okay, now let's see the uh, s- purpose of gain. Video. Stop. Okay, let me show you live exposure. Uh, Switch off gain, change the iris. I'm going to make it dark. Okay, so even with the lights are on, you can see here, even after I switched on the lights, actually this, I'm sitting in the training room, the lights are on. Now, because my f-stop is so high and no gain, you see it is dark. Okay, now see the power of gain. When I make it gain control, automatically make it, let's say star middle, you see it is increasing whatever light the camera is receiving. Okay, lights are switched on, that doesn't matter. How much of light is going in the camera is so less. Without gain, it is so less that it's thinking it's all, there is nobody there, right? It's very dark. But gain control can amplify that. Whatever is coming in, it can amplify and can make it as good as day. So that is the power of gain control. How good the image looks, it can make it day to night, or night to day. Sorry, it can change a night situation to day. That is through gain control. So gain is very powerful setting, and it is always used. Almost in every CCTV you will see it is used. So if I make it high, okay, not much change. So now that is gain. Now if I tell the camera, okay, get take more light, Okay, you see the image, if it is bright, but it is not very crisp, right? So blurry and it's not very good. So you can say, okay, take more light, or you can just say auto iris. You choose how much of light to come. So now you see how the image got adjusted, much more crisper. So it removed all the noise and other things. So when you have a lot of gain with high f-stop, you have this noise reduction, 2D and 3D. We can see that later, but basically noise reduction. When there is some movement, it will be very, very blurry. It will not be very crisp. Okay. And for example, so you see, I just threw something and you didn't really, it was not very smooth. Okay. So that is because of all this noise reduction. That is also referred as ghosting. Tomorrow we will see more about this and how to adjust it, so you will get more solid and concrete information. So roughly speaking, there is we saw about this gain control. That is good, but it's a triangle. Everything has to be adjusted correctly to get the right image. You cannot improve everything simply to get a good image. All right. So gain, it the main purpose of gain is to increase the brightness of the image night to day, but side effect is image noise. So there is something called fine balance, how to adjust the scene. So we will see that tomorrow, and I hope today's session was useful. And the session for today is completed.